Hi everyone, today I will make one of Heusler's compounds. This is not a tutorial, do not repeat anything shown in the video. About 2 months ago, a viewer suggested I try to prepare Heusler's compound by an aluminothermic reaction. First, I had to Google what that is. In short, a Heusler's compound is a magnetic intermetallic that can be prepared from non-magnetic metals, and there are a lot of options to choose from. So it seemed easy enough. I chose Cu2MnSn, that is an intermetallic composed of 2 moles of copper to 1 mole of manganese to 1 mole of tin.
What are we waiting for?
I weighed out 10 grams of manganese oxide, 4.13 grams of aluminium, 14.65 grams of copper metal, and 13.6 grams of tin. The idea is to use the heat from manganese thermite to alloy it with tin and copper in the right stoichiometric ratio. I carefully and thoroughly combined the reagents, transferred the mix into a hollowed out foamed concrete brick, and topped it with a mix of magnesium granules and powdered rocket candy. Then I took it to the advanced test facility and lit it with a bit of slow match on a stick. Yes! This one was nice. To anyone wondering why I haven't posted anything for a month, I started the process of getting myself a master's degree and was studying for a math preterm. For anyone wondering, no, it did not go well. Now, let's see if this little thing I do on the weekends and when I have time to blow off some steam and have fun succeeded. Let's turn on the light. Atop we have magnesium and aluminium oxide. Let's pour it off. Here is we hit a layer of material that's a bit more compacted and welded together. Biggest piece of copper did not melt. Not a good sign. I really should have used copper powder, but I didn't have any pure one on hand, so it is what it is. So far it looks like most of the mixture reacted, or at least welded together. But yeah, there is some unreacted here on the side. Not the greatest thing ever, but perhaps until we test the material for ferromagnetic properties, I won't yet give up. It's still warm, so let's test first other material. Oopsie daisy. I know this is magnetic. Oh, we've got something that flew up to. There is a bit of magnetic material. there is something magnetic. It appears we have indeed made a bit of Heusler's alloy, if I'm even pronouncing it correctly. I took only half a year of German once, so I have no clue how I should pronounce it. Yes. Okay. Looks like there's a little spot on this piece that somehow managed to hit the right 2:1 ratio of copper, manganese, and tin, and in fact produced Heusler's alloy. Very good, very nice. Oh, this too is somewhat magnetic. I'll take what I can get. Let's see if this thing... Nope. I'll hit it with a map gas torch just in case, because I see there are tin granules welded to it, but not melted, and adding a bit of tin to copper manganese mix might get us something that will stick to a magnet. I crushed this big lump into smaller pieces of material. You can see there's still huge pieces of copper. I really shouldn't have added, but wisdom always comes after the fact, so I better remember this for the next time. But let's see if let us see if sintering made any more of the alloy. Okay. There's a bit that stuck. This bit also. Yes. Let's... Oh, very good, very nice. Yes, sintering did help a bit, and if I done it properly with under inert atmosphere and for like 5 hours, it would have surely produced a good piece of alloy. The fact that I managed to make some with such an incredibly ad hoc improvised method is kind of surprising and a big win for me. The process I just demonstrated is far from optimal, but it works, so it could theoretically be improved and perhaps used for something actually productive. Thank you for watching, like, subscribe, and see you soon.